Well, hello people. This video is going to talk about how to graph a real-life situation. Not just any situation, a sinusoidal situation. That's a situation where there's something periodic going on, okay? When I say periodic, something that can be represented with a sine or a cosine curve, often called a sinusoidal curve, okay? That's how you spell it. And things in real life that might have to do with this are, for example, tides on the ocean, sunrise and sunset data from year to year, temperature data from year to year, even though things are getting warmer, they say. What else? Well, today we're going to be looking at a question regarding a Ferris wheel. And hopefully the Ferris wheel won't go below the ground, or else that would be a problem. The people would be injured. You want the Ferris wheel to be going up and down kind of like this. But anyway, we're going to graph real life situations given the information we need. And without saying anything more, let's get to it. Now, first of all, a question like this, where they give you the equation straight up like this, if you're allowed to, you can go ahead and just go to a program like Desmos, punch that equation in, and graph it. However, in this case, we're going to sketch it just to show you that we could do it ourselves. But then I'm going to quickly show you using Desmos as well, just so that you can see how to model this using Desmos as well. And then we can answer all kinds of questions right down here at the bottom. Okay? Feel free to push pause if you want to see those questions, but what I'm going to do right now is start by sketching this thing. Okay? So first of all, I'm looking at this, and the very first thing I start with is this number on the end here. Okay, I look at that, +2. And remember from the last video we looked at, and there are multiple videos on these sinusoidal curves that I have made. So I'm going to graph, or get the graph down here, like that. And +2, well, there's 1 and there's 2. +2, you know, I really could use a line. Perhaps I'm going to do that. Let's do that. We might as well get this right. Where's the line option? Sorry, this is going to be so much quicker. Okay, there's +2. It's a little bit thick. I think I could reduce there we go. That's a little better looking, right, folks? There we go. So right there, that is at 2. Okay. Now, what is this called? At the end of an equation like this, this part right here, do you remember what that's called? I'm trying to remember myself. Just give me a second. Normally I would wait for the class to yell it out and I would say, that's correct. But in this case, I have no class in front of me. I'm just speaking in front of a laptop. So I call it the axis of the curve. Some textbooks call it the equation of the axis, and there might be other words that some textbooks might even call it the median. But I'm going to call this the axis of the curve. Okay? So in other words, it's the middle. Okay? Now from there, the next step is, and I'll continue writing in red, we're going to deal with the amplitude. The amplitude says how high it goes up from this axis of the curve. So this number in the very front here is a 5. And don't worry if it's positive or negative, because 5, the amplitude is always positive. The negative would just mean your curve is being flipped upside down. So we have a 5 here. That means it's going to go up 5. So 2, 3, 4, 5. It's going 5 up. Our curve is going to go from here 1, 2, whoops. Do you see my mistake there? 2, 3, 4, 5. We need to go like this. 2, and then from there, it's going 5 up, not up to 5. Do you see my mistake, what I made? I'm going to push pause here. Someone is knocking on the door. Okay, I'm back. Sorry about that. Now the mistake I had made before was I went up to 5 on here and put 5 there. That is a mistake because the amplitude is the distance that the curve goes up and down from this point right here called the axis of the curve, okay? So it's going to go 5 up and 5 down, just like the axle on a car, okay? The wheel goes up and down around the axle of the car, okay? So in this case, 2, here we are, there's 1 jump, 2, 3, 4, 5. We are going on an amplitude of 5 up and 5 down. So let's write a number up here. It's not the number 5 this time, okay? 2, 3, 4, 5, 6, 7. So it goes 7 up. Let's go down now. So we're at 2 here. So remember, there's another dot right here. So 1, and there's 0. So 1, 2, 3, 4, 5. It goes all the way down to -3. Because -1, -2, -3. So our curve goes all the way up to 7 and down to -3. When you're asked a question like A right here, it says, what are the maximum and minimum heights of the tide? You could say, we could answer that right now. We could say, and I think this is talking about h is the height of the tide in meters above or below sea level. So the maximum is 7 meters above sea level, and I'm just not going to write that here because I don't have the space. And the minimum height is 3 meters below sea level. Okay, sea level would be right at 0, which is right at this green line right here, the x-axis. Okay, so the maximum is 7 meters, the minimum is 3 meters below. We could have answered this without even graphing this thing like we're doing right now. We could have just looked at this 2 up here, added 5, that would give us 7, and we could go 2 minus 5, and that would give us our -3, which is 3 meters below sea level. I had room to write that, so I just threw it in. Sorry for my bad writing. Okay, the next questions though, I mean, we were able to answer this one, but we can't answer this one yet. After midnight, what time does the first low tide occur? What time does the first high tide occur? We can't really figure that out until we draw this thing out a little better. Okay? All right. So let's draw, I don't know, the next, should I use blue or pink? I'll use yellow. Okay, so the x-axis here. Let's look over here. We've got 2 things going on. We've got t minus 4. Do you remember what that means? If you've watched the other videos that I have about this stuff, we know that -4 means that this graph is going to go 4 to the right. 2, 3, 4. And if you've watched the other videos that I have, you'll know that sine is a curve that starts at the median or starts at the axis of the curve and goes upwards, up and down, okay? Now in this case, because it's moved over 4, it's not starting right here at the y-axis like it normally would, okay? I'm just making sure this is recording still, yep. So what we're going to do is we're going to shift this over. Instead of starting up right here, we're going to start up right here. Okay, that's where this sine curve is going to start, at 4. That's where it's going to start moving up. If this had been -5 sine, we would have went down at this point, because sine always starts along this line right here, which is called the axis of the curve or the median. So let's keep going here. The next thing we need to know, if we're going to put more dots down and see how our curve is drawn, we need to deal with this 30 right here. See that 30 that I just circled with this yellow pen? Do you remember from previous videos about sinusoidal curves? The period is 360 degrees divided by k. K is the value that you see in the equation. What we have right here is k. So period is really 360 divided by 30. Remember, 30 is the value that is k in here. To graph this, we need to know the period. So that's my little question mark. We need to know this. So 360 divided by 30 is, and if you do this on a calculator or you do it in your head, 36 divided by 3 is really the same thing as 360 divided by 30. You should come up with 12. So with a period of 12, that means that at 4, we know it's going upwards, right? That means 12 points after this, it's going to be repeating and doing the exact same thing and going upwards again. So, I don't know, 4, 5, no, that's actually, no, you don't count 12. You don't end up with 12 over here. You go 12 points, just like before. We went 5 up from the 2. We're going to go 12 beyond here. So we're going to go to 12 plus 4 is 16. So 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16. Wow, you folks are probably saying, just use Desmos already. Sometimes you're asked to graph this stuff, just sketching it. So I'm just trying to show you. Okay. Now, what we're going to do now is figure out some other dots here, where some other points are. Halfway between 4 and 16 is going to be a midway point, because we're going to be going up, then down, halfway between these two, and then we're going to be coming up again. And the cool thing is, things are usually happening halfway in between the special points that we have. So between here and here, what number would that be? Just add up 4 and 16. You will get 20, and divide by 2. You get 10. 4, 5, 6, 7, 8, 9, 10. Right here is 10. So at 10, this curve is going to be going downhill. Okay? Now let's figure out the maximum point. It's going to be up here somewhere. What number would that be? 4 plus 10 is 14. Divided by 2 is 7. 4, 5, 6, 7. That's kind of a fluke, but at 7 in the morning, it's going to be at high tide, which is 7 meters high. And then we start to see our curve forming here. But we can't keep going because I don't really know where it is here. 10 plus 16 is 36. 36 divided by 2 is, can you remember, folks? 10, 11, 12, 13, 14, 15, 16. 15, 14, 13. Sorry, 10 plus 16 is 26. 26 divided by 2 is 13. Man, I was confused for a second there. I'm sorry. And then the point is going to be at the lowest point at 13. And it's really hard to see that because I did the numbers in yellow. But I'm going to try and draw this. Okay, I'll just put an arrow there because we're not going to keep this painful drawing that I'm doing for too long here. We're not going to keep going too long. Now, let's see, where's the next low point going to be here? It's every 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. So 1, 2, 3. That's going to be the low point. I'm just going to draw this until we get to the x-axis here, or to the y-axis. There's my arrow. So the low point is going to be at 1 there. And now we can answer the question down below. It says, after midnight, what time does the first low tide occur? Okay, midnight is at 0 right there. At 1 in the morning, we can see that it hits the lowest point right there. So that would be low. The low tide is 1 a.m. Okay, what about the first high tide? The first high tide occurs right up here at this spot. And at what time in the morning is that? 7 a.m. So the high tide is at 7 a.m. Okay, what is the depth? Now we can go on to the next question. We've answered that one. What is the depth of water at 10 o'clock in the morning? That would be right here. The depth of water at 10 o'clock in the morning is right here. Thank goodness it's a nice spot that's easy to see. The depth should be 2 meters above sea level. The depth is at 2 meters. And I would write above sea level if I was doing this in pencil. Last one. Could you model the graph using the cosine function? Wow. Modeling the graph is when you actually write it out, like as an equation. Okay, so for a question like this, remember cosine starts, and the last video talked about this, cosine starts at extremes, either the very top or at the very bottom. Okay, in this case, I'm going to stick with the very bottom because it's so close to the y-axis. But we're going to have to remember how far over the cosine, if you flip it upside down, will start right here on the y-axis at the bottom, at an extreme bottom. A normal cosine graph would start at the top and move downwards. So we're going to be talking about a negative cosine curve because we're starting from the bottom. Okay, and pretty soon when we deal with this part of it right here, the phase shift or the horizontal shift, we'll have to talk about it moving 1 over to the right because we're not right on the y-axis here, we're 1 over to the right. But for now, the good news is if we're writing this as cosine, there's a lot of things that stay the same as when we had sine. For example, the amplitude, it's still 5. Okay, it's still going 5 up and 5 down. The number on the end is 2. That will still stay the same, but we'll get to that. So we're going to have negative 5 cosine. I hope you remember why it's negative. It's starting from the bottom instead of the top. Now we can put in the exact same period. That doesn't change. Okay, the exact same value for k, which is 30. Then in brackets, we're going to write t. I guess I could have called this x as well. I'm just putting t here for now. I should have had f at, or h at t right here. But anyway, please don't let that bother you. I'm going to have t, which is an annoying number because it looks like a plus sign. It's an annoying letter, I mean. Anyway, minus, I'm putting a 1 here. Why 1? Because this whole sinusoidal curve has moved 1 over from the y-axis. Okay? And the last number is the axis of the curve, which is still 2. So this would be our equation. If we were to write this using cosine, this is what it would look like. I'm going to quickly graph this, showing you how to do it on Desmos so you can see what it's like. And then this video, instead of continuing on, I'm going to stop because it's just going to get too long. So I'll do a part 2. I'll call this part 1 and the other one part 2. Okay, so we had negative 5, and it was sine 30, bracket x, was it minus 4, and then plus 2. And I think that's what it was. It looks crazy on here right now. That's because we need to set Desmos up. So what you do with Desmos, the free online graphing calculator, hit the wrench sign that says graph settings when you hover over it, and change it into degrees. Things will immediately start looking better. And you start to see the graph that we have here. It wasn't negative, was it? It was positive. Now it's starting to look even better. Here, I'll make this thicker, put it in projector mode. I'm going to set things up to make this be step. For the x-axis, I'm going to say step 1, just so that we can see all the numbers in between. Okay, does this look like the graph we just graphed? Look how quick this was. Is that true? Negative 1 and negative 3? Down here? Yeah. Sorry, I mean 1, negative 3, not negative 1, negative 3. 1, negative 3. And the next spot here, well, we didn't really talk about that spot, but we did talk about this spot, 7 and 7. We talked about this spot, 13 and negative 3, although we didn't really talk about it. It should be there. 13 and negative 3 is right there. And these spots here we didn't really talk about. But how would you draw in the axis of the curve using Desmos? What could we do to put in the axis of the curve? Because the axis of the curve is so neat to look at. Well, all you do is type in y equals, I believe it's at 2. You hit that, and right away you can get a nice different colored line showing you similarly what we had. And it even shows you the points where it meets up with 4 and 2. Let's see if that makes sense on our graph. At 4 we were too high. It's exactly correct. Pretty cool, eh? You should have 10 and 2 as well. Let's look for 10 and 2. 10 across, 2 up. There it is. And the cool thing with Desmos is you can keep going, and they could say, 24 hours from midnight, where's the graph at? What's the tide at? 24 hours after midnight. And you can see at 24 hours it would be about 2.33 meters below sea level. There's all kinds of questions they could ask us. And we could now answer using Desmos as well. So using technology with this stuff is very useful for sine curves like this. Okay, we could test out that we got things correct when we typed in cosine. We said -5 cos 30. We said x minus 1. See how it's starting to become the same thing? And we said +2 on the end. Next thing you know, we have a green sine curve that overlaps the old red one from here. Because they overlap each other, we know that our guess for this was the exact same as this, and therefore we know we got the exact right answer. You probably won't be given such a nice chance to do that on a test. Your teacher may not allow that, but at least you can see how that works so that when you guess and when you practice, things will make sense. I'm going to stop this video here and call it part 1. Have a great day, people.